Uh, who's supposed to speak now?
All of the chairs are coming up on stage, and what we'll do now is we'll invite people to come up from each table to report out on their discussions. I believe the first person to report out is Jamie, and she's already here. Jamie for table 11.
Yeah, I accidentally put my name in the reporter slot, so so that happened. But so we had I loved our discussion. It was such a great group, and I'm realizing I did not screen capture my whiteboard, so I'm gonna have to try to do this by memory, I guess. Leonard, I know, wanted us to start with the first 4 questions so we wouldn't get bogged down in the question, how do we grapple with the ethics of this? But it was something that we all had to like get off our chest. So we were in the storage permanence group, so not looking at a specific mechanism for CDR, but like something that applies to all of them. But the first thing we need to do was get it off our chest that we do not, as scientists, want to give cover to people who say CDR will can allow us to delay, defer, displace emissions reductions. And so we thought it was really important to just lay it on the table that this should never be seen as at odds or in competition with emissions reductions. And we wanted all research done on this to have almost on a box of cigarettes, the stamp that says smoking will cause lung cancer. We wanted to say CDR does not displace ocean emissions reductions. And so once we kind of cleared that off our chest and understood that CDR should be thought of as taking away historical emissions, the last very hard to decarbonize bit, that it's also we liked, or I personally like the idea of planting a whole garden of mitigation solutions, and that this is one row in your garden and that we need to tend to the whole garden, and you don't plant a garden just by pulling weeds, right? So we have to put it as part of the suite. So once we got that off our chest, then we started working through some of the other issues. We talked about the knockout criteria, and we kind of agreed that in terms of permanence, it's not going to be a 0 or a 1, a binary choice between when something's knocked out because it's too short term in terms of its storage, but rather that there's a continuum, that a decade would be too short and 100 years would start to be interesting, and then there's some gray zone in between. So that was our conversation. I'm doing this all by memory now, darn, of the knockout criteria. In terms of where the state of the knowledge is, that question number 1, we realized that permanence doesn't have a definition. If it's not in the sediments, thank you, Heather, so great. So that permanence needs a basic definition. If it's not in the sediments, which is legitimately thousands of years, but in the deep ocean, then it will be there will be a spectrum of reemergence times that will influence how long it stays down. So what do we mean by permanence? We need some working definition of that. So that's the state of the knowledge there. And then we were all stumped by the question of how to understand the permanence of alkalinization, because it's very different than getting the carbon into some layer of the ocean, sedimentary or deep ocean. It works even if it's in the mixed layer, but not in our group. We were processing and a little bit stumped on how to define permanence when the alkalinization affects the mixed layer, even if it were to stay in the mixed layer, how long that works for, even if reduced by the fertilization effect on calcifiers. So maybe a question for Roz, if she comes back. 2, what do we really need to do? We need metrics to evaluate which models are most useful. Julius's talk showed beautifully that there are models that are going to give very different answers with respect to permanence. How do we tell which models are kind of out in left field and which models are most useful for that? And we want to understand tools to engage communities beyond our usual circles, the kind of things we were talking about with Candace, and more broadly than just than indigenous communities, but everyone. How do we bring the science to the people who we're trying to serve, and defining who we're trying to serve and where the tools are for that? So we want better tools for making that happen. And then I think I did 4, so I'll just finish with 3. What hands-on research? We realize that modeling in this sense is a very ripe area. You can do it without consequences to the ocean environment. So we want improved models for small scale physical processes, and making sure that they're working by comparison to observations. But we ended the conversation talking about how you would do an actual in the ocean monitoring. So if, as just an example, if you were to do an alkalization experiment in an estuary, or to monitor the air sea fluxes in that estuary to understand if it was working or not, and how long it was working for. So I don't want to take up too much time because I know we have a lot of groups. That's where we were.
Amy.
Thank you for saving the day with the whiteboard.
I think it was Beatrice who saved the day. All right, next up we have Patrick Gray for floor 1, and he's already been brought up to the stage because e-poster boards folks are fabulous. Go ahead, Patrick.
Great. So we were discussing basically alkalinity in the surface ocean as a way to sequester carbon. I think the basic takeaway was that there were a ton of unknowns, and really a lot of debate on the best approach. And so we tried to tackle initially just quantitatively how much carbon could it sequester, and we didn't really get anywhere on that. I think that just the exact approach is unknown, and the scale of it is challenging. And so then we were discussing there are all these competing options, but the basic idea, we all at least roughly nodded that the basic idea of increasing alkalinity is feasible, at least on some level. But like, are we actually going to grind up terrestrial material to a micron for proper dissolution? And there was a lot of doubt on that front. And let's see, so another key bottleneck that we went into before we discussed some specific methods were, does the alkalinity actually get into the ocean properly? Does it stay in the surface ocean long enough? Let's say 1 to 12 months. And almost regardless of the method, we need to ensure that that's the case, or else it's just a knockout. And then if that actually works, does the CO2 actually make it in the ocean? And the key bottleneck that Ross brought up was how much CO2 is getting in per the amount of alkalinity, and how long is it staying? And we spent the bulk of the time discussing some recent work on splitting water into hydrogen ions and hydroxide, and then pumping the acidity into the deep ocean to increase alkalinity. And there was a cool paper that just came out from Google on this. We were discussing impacts on biology. So maybe in the surface ocean, we're just returning it to pre-industrial levels of acidity. And so maybe it's fine in the surface ocean, but in the deep sea, the impacts could really be severe of increasing acidity in the deep sea. And of course, on average, maybe it's minimal, but if you're pumping it to a specific spot. And then there's some doubts on how well you can actually maintain the gradient of pH in the face of particularly meso and submesoscale vertical mixing. Then is there a way we can neutralize that acidity in the deep sea to help mitigate some of the local impacts? Brendan was saying that the goal of this was to keep the pH below 9, so that these local impacts aren't too intense. And Barney had some thoughts from the ChalkX work on these pretty intense optical side effects that may happen in the surface ocean. And then one of the last key questions for this method or others was, how does that alkalinity disperse in the ocean? Does it stay hyperlocal, or is it properly mixing throughout the surface? So lots of good discussion, along a few different lines.
It sounds like you guys covered a lot of ground. I was going to ask about unintended side effects, and you mentioned it right there at the end with the optical side effects. So thank you, Patrick.
For sure.
And just so everyone knows, we're saving all of these whiteboards, so they'll be available. They'll be we're planning to share material after the workshop, but they will be available for further discussion after the workshop too. So. Anand, you're up next.
Hi, Heather.
Hi.
So, do you have the whiteboard, my whiteboard?
Can somebody share a screenshot of it in the chat? I don't have it.
I think, okay.
Doing that, I think Dave points out that if you can get the HCl out of the ocean, you can use it for industrial needs so that you don't acidify the deep ocean. I think that's a neat comment from Patrick's share out.
Yep. Okay, so we talked a lot about technologies, and we did try to hit all of the 5 major questions. And we tried to go across the different technologies. Our group had Bob Anderson, David Coeek, Erica Ombres, Rue Nicholson. I think I got everyone there. Oh, and Kathy Tedesco, who graciously spent her time recording. So the one theme that sort of goes across all of these is the question not only of impacts but additionality. And so it's one thing to say that there's permanence. There's another question that comes up. Can you actually tell that there is permanence of storage, and permanence relative to what? You know, there's wide recognition that the whole question of how has one changed preformed nutrients is a very difficult one to answer for things like ocean fertilization. And there was, in fact, a question about whether we should even be thinking about ocean fertilization at all. On the other hand, for something like alkalinization, so we also talked about, we talked about ocean fertilization. We also talked about artificial upwelling, and those were the 2 main things that we talked about. For artificial upwelling, the question of the question of scale, impacts on weather, impacts on hydrography were raised as areas where we need to have more work. For tools, things like better models, higher resolution models also came up. And the ethical questions, we also, like Jamie's group, spent a fair amount of time talking about the ethical questions that this raises. Things that I think are worth highlighting are the environment that we're in right now, where expertise is devalued, it's often because of own goals on our own part, right? And how we hold ourselves accountable and how we invite criticism is actually a fairly important part of gaining public acceptance for this, right? And something that we haven't always done a very good job with. In terms of the third question, hands-on experiments, one question that came up is whether we should be interacting more with the ocean thermal energy conversion community. That there might be some interesting opportunities there. And I think that's most of what we talked about. I will turn it over to the next person.
Let's see who's next.
Aurora.
Hello, can you see me and hear me? Okay, so I am reporting from the group discussing about ocean afforestation. I have the same issue with words. I don't have it. I'm really sorry, but I'll do my best on this. So we had a really nice group and a really nice discussion with many questions coming out, not only the 5 that were posted by the conference, but others, and a lot of debate. One of the things that came out at the very beginning is the definition of afforestation. Some of us were a little bit confused on exactly what it means, but the discussion has been focused on seaweed farming and sinking of that seaweed. And so what is the state of knowledge with respect to that? We believe, all of the attendees, we believe there is still a lot to do in order to scale up and to scale up at the big scale, really understand if this can be a tool for carbon sequestration or carbon removal, and especially to predict future work and future consequences by climate change. And one of the things that came out is that even if there are sectors that want to implement this already, from the scientist perspective or from the evidence perspective, there is still a lot that we still don't know and a lot of work to do in the next coming years to make it work and to be effective on this natural-based tool for mitigation of climate change effects. So what tools or what studies are needed to reduce uncertainty on this quantification? So the issue is about quantification. We can't quantify right now at the big scale if this is gonna be, I mean, it's a solution, but what's the effect, what's the relative importance of that solution? So we need verification tools. This is work that is already happening, but is developing right now. And one of the things that came out is that we need life cycle assessments for seaweed farming, different species, different habitats. All this needs to be taken into account, especially to quantify the composition rates in the deep ocean. And one other thing that we don't know is how long this is gonna last, meaning how many years organic material coming from seaweed can stay stored as a stock, not being decomposed. So we really don't have numbers for that, and that's a need. So what other research or what research is urgent right now, and what is the potential funding source for this? We need to establish numbers, that I was saying, especially to do scaling up, to do modeling, to quantify. And funding right now for all this seaweed work comes mostly from private sectors and a little bit from the public sector, but matching funds between both would be a really good strategy to keep doing this work. So knockout criteria, next question, that can be identified that would suggest this solution not being viable. It's, I think we all agreed that it's social acceptance. I mean, even if this can work, social acceptance or social license is essential to make it happen. And this is still in very baby steps right now. And so from the ethical part or ethical issues that this can have, we actually don't have answers on this. We just kept going with more and more questions, and so there is a big gap in knowledge in what are the ethical issues of sinking seaweed at big scales for carbon removal. And I think that's mostly it. We have more questions, more debate, but I can stop here for now.
Thank you. I see next in the list, Twining.
Right, can you hear me? Great, all right, thanks. So yeah, so I'm here to report on the OIF group, or one of the OIF groups, I guess. And we had a great group with Julian Yoon and Matthias Odo. Tagliabue, John Lauderdale, Nina Schaubach, Dave Emerson, and myself. And yeah, I'll just give a couple. I knew to take a screen grab of the whiteboard, but lots of people added things at the very end, and the warning to leave the session covered half the whiteboards. I have a dated whiteboard today, but let's see. You know, I think in terms of the state of the knowledge, OIF is probably the most mature, if you can use that word, of these CDR technologies for the ocean. And certainly, you know, there's a long history going back 30 years or more of theory and modeling providing an upper limit in terms of capacity for ocean fertilization to impact carbon removal. But we all certainly are aware and noted that we have those upper limits, but that actual OIF experiments have generally had, you know, pretty mixed success in replicating that in the ocean. And certainly the IFEX study, the Smitacek study, showed really good carbon removal or effective carbon removal, but most of them haven't. And that got us talking quite a bit about the variability and the massive variability in the ocean and the conditions that are needed, the sort of Goldilocks conditions you might need to get the kind of removal that would be hoped for. And so in terms of, you know, studies that we need to do, a lot of it, I think, is about understanding ocean variability. And we talked a lot about the co-benefits of learning more about controls on biological carbon pump and ocean productivity in general, right? So even if OIF is not going to save the day here, and I think it's probably not, learning more as we are from things like BioArgo and many of the studies going on in exports about controls on carbon export will benefit both our understanding of OIF efficacy and also just ocean biogeochemistry. We talked in terms of other tools and studies needed, certainly more understanding of the response of carbon export and deep ocean return timescales for carbon to come back up. And Veronica's sort of highlighting of that in her talk was really, really useful. We talked a bit about what we can learn from studies of the geological past, may inform about losses of productivity to inputs, but noted, you know, some of the complexities that introduces, for example, differential circulation that was probably present in the past. In terms of hands-on research that could be most useful, I think there's still a lot of uncertainty about bioavailability of different forms of iron and how that might impact or control what you did. How do iron delivery mechanisms matter? Again, all the sort of existing OIF experiments used really the same method of putting iron sulfate in the water and dragging it behind a boat. How much, you know, are there other ways you could do it? For example, dust-based ways or airborne ways that could change the effects. Are there hotspots for export? Again, going back to our understanding of the natural system, and that we would be, if this was to be done, trying to overlay upon. And also a really important one is studies that understand how iron and other nutrients may be decoupled from carbon during remineralization, because that's really what you want to do. You know, what we're doing in fossil fuel extraction is removing the carbon, but not the other nutrients, and we want to stick the carbon back in, but not the other nutrients. And how does that happen naturally, and are there ways to enhance that artificially? In terms of knockout criteria, I think we pretty much agreed on three, and these are not new to everybody here, but certainly efficacy. You know, does it make a difference and make a dent in atmospheric carbon dioxide? Verification, even if it works, does it matter if we can't verify it? And we talked a bit about, you know, is verification actually sort of effectively impossible for this, to be given the huge variability in and uncertainties about carbon export in the biological pump. Talked a bit about whether there are lessons to be learned from the climate modeling or the climate community and the climate modeling community about attribution, which is sort of the flip side or another way to think of verification. If we can't, you know, how do you attribute human impacts to climate change? How do you verify effects of OIF? And again, getting back to the needs to understand this natural variability in order to overlay any action over that. And finally, we really our focus on the ethical question focused on the nutrient robbing or nutrient stealing issue. Before, you know, the fact that fertilizing typically very far offshore international waters is expected by models and our understanding of ocean circulation to reduce nutrient delivery to lower latitude systems, where they can, be important for supporting fisheries. And so that's really where issues of ethical and equity come in. Really, basically, increasing productivity one place to decrease it in another place. That really deserves attention by research efforts and discussion. So that is my effort to summarize our talk.
And
Sure.
our last reporter is Michael Winchester from the Blue Carbon.
You can hear me?
Yep.
Okay. So I got kind of strapped into this. I'm brand new to this community. So if I say something that's just wrong, please forgive me for that. But we were in the blue carbon session and discussing the 5 questions there. To summarize what our thoughts were, I think seemed to be a consensus that blue carbon holds promise for making a dent in the carbon dioxide problem and global warming. Whether or not it would be localized to just a general area of a particular coastal area or global depends on the acceptance of the blue carbon strategy, how broadly it is accepted. So that can be considered to be a knockout criteria, really, I guess, if, and this is what we discussed with in terms of the knockout criteria is more political and social acceptance. I think I've already heard that in the other breakout session reports, just how widely accepted it is taken to be. Along with that, with the 5th question, the ethical community-based questions, it was pointed out that a lot of times there are competing priorities that can all be environmental in nature, but still they're competing. For example, whether you protect the sea turtle population or want to grow seagrass. If there are too many sea turtles, then you can't grow seagrass because the turtles eat the seagrass. So what do you do with that? So there are questions with that need to be answered. In terms of the research that needs to be done, what was mentioned there is that it's not known what happens with certain events, such as a hurricane or an earthquake, I guess, is a possibility as well. Just exactly what happens there with the blue carbon effort is not known, so research needs to be done there. And we spent quite a bit of time actually discussing what the NIST role could be. I happen to be from NIST, the National Metrology Institute of the U.S., and there weren't many people in the session really, so we ended up spending quite a bit of time talking about what NIST can do to help with this. And the answer is with providing the measurement tools that are necessary to understand and quantify the effects of blue carbon sequestration efforts. Fit to purpose, not necessarily always the best metrology tools are needed, but they can be just what is fit for the purpose to answer the questions at hand. So, an understanding of the problem, whether or not NIST could provide reference materials or provide test materials, which are not actually full reference materials. We have the capability to do that. So there are a lot of places where NIST could contribute with blue carbon, as well as the other areas that have been discussed in the last half hour or so. So, if anybody has any ideas, please feel free to contact me with regard to that. But Heather, you were also in the session. I don't know if I missed anything important, but that's what I remember without having the whiteboard in front of me. So.
Full of notes in the chat, but I think you captured everything.
Okay, thank you.
All right, we're a little bit over time, but this discussion was so worth extending for. So I'm really excited. People stuck around for this important talk. We got at least one report out from each topic, which I was really hoping for. Like I said, all the whiteboards will be saved. This discussion, not the small group discussions, but all of the discussions we've had here on stage have been recorded and will be put on the website. So I just really want to thank the chairs and the speakers again for a fabulous session. I want to thank all of the participants for the great discussions that you contributed to over the last hour. And I want to encourage everybody to maybe take a quick bio break if you need one, and then head right to the poster sessions, because we'll be convening in the lecture hall at 11:15 promptly for agency reports. So I don't want to shortchange our poster presenters. So please, quick potty break and then right to the poster sessions. I don't have a bell, so thank you, everybody.